¿cómo estás? Today we are going to learn some literal equations for algebra. Okay, so literal equations are a little different, okay? So literal equations are equations that have more than one variable, okay? So it's an equation with two or more variables. Okay, what it's used for a lot is like formulas. You'll see it in science a whole bunch. You've already did one in science that you probably didn't even realize. But as you go through science, you'll see it a whole bunch more. And then like when you're finding like surface area or volume and things like that, and like they give you the surface area and you got to figure out what the height is, and this is where it's useful at. Okay, so what we have here is a regular one-step equation. Okay, this is a regular one-step equation. How would I solve this? X plus 7 equals negative 12. How would I solve that? Well, I know I have to do the inverse operation to get rid of that plus 7, right? So I have to do minus 7 because that cancels out and makes 0, and that's going to leave me with x, right? And I'd have to do the same thing to this side. And negative 12 minus 7 would give me negative 19. Okay? So that would give me negative 19. All right, so let's look at this. This one right here, it's all variables. So it looks kind of scary at first, but it's the same steps as what we do when we're solving equations. It's just having more than one variable. So if I'm solving for a, just like I was solving for x here, that means I have to get rid of this plus b. Well, how do I get rid of a plus b? Well, it's the same thing as getting rid of a plus 7. I would do a minus b. I would do a minus b, right? Because that would cancel these out. Because a positive b and a negative b, they would make 0. And that would leave me with a on this side. All right, so then what do I do on this side? Well, I have to do the same thing. I got to do minus b to this side, right? All right, so can I do c minus b? No, I can't, because they're not like terms, right? So my answer would just be a equals c minus b. And that would be my answer. Okay? Let's try another one. All right, so y minus 9. How would I get y by itself? Well, I would do the inverse operation. I would do plus 9, right? So then I would cancel those out, and that would leave me with y. And I would do the same thing to this side. I would do 34 plus 9, and that would give me 43. So I'd have y equals 43. So if I was doing this example here, it says solve for d. I have d minus e equals f. So once again, it's all variables, but it's okay. I just do it the exact same steps as I would a regular equation. All right, so I'm solving for d. D is right here. Same thing as my y spot here, right? Sometimes I like to circle my variable so that way I know I have to get this by itself. And that helps when there's a lot of multi-step ones. Okay, so how could I get that d by itself? Well, I have to get rid of this minus e, right? So how do I get rid of the minus e? Well, I would do a plus e. And I would do the same thing on this side, right? Minus e and plus e cancel out and give me 0, which is what I want. And then that's going to leave me with d over here. So it's going to be d equals, can I do f plus e? No, they're not like terms. So I just write f plus e. And then that's my answer. D equals f plus e. So you're doing the same steps that you would as a regular equation, but it's just with variables instead of numbers. Okay? All right, here's another one step. I get negative 6x equals negative 30. Well, a number next to a variable means multiply, so I know I have to divide by negative 6, because negative 6 divided by negative 6 gives me 1, and I want 1x. That's what I'm looking for. And I got to do the same thing to the other side. Negative 30 divided by negative 6 would give me a positive 5, because a negative and a negative make a positive. 30 divided by 6 is 5. All right, so let's say I was solving for r. Here's r. What's happening to the r? Well, I see a 2 times pi times r. That's what's happening, right? So if I want to get r by itself, and all these are being multiplied, I would divide by the things I don't want. Well, I don't want 2, and I don't want pi. So these would cancel out. Pi divided by pi gives me 1. 2 divided by 2 gives me 1. So that leaves me with r. So what do I do over here? Well, I do the same thing. I divide this side by 2 pi. Can I simplify that anymore? No, I can't. So then that's my answer. My answer would be r equals c divided by 2 over pi. All right, let's try this one. I have y divided by negative 4 equals 8. So if I was going to solve this, I would do times negative 4 to get rid of that negative 4 and leave me with y. And then over here, I have to times it by the same thing to keep my equation equal. So then I would do 8 times negative 4. Well, 8 times 4 is 32. A positive times a negative is a negative. So I would do negative 32. And this is the formula you'll see this year in science, okay? All right, so let's say I'm solving for m. M's up on top here, right? Well, it's the same thing as I was doing this when I was solving for y. That's up on top. M is being divided by v, just like how y was being divided by -4. So if I wanted to get m by itself, I would times by v to cancel out those v's and do the same thing to the other side, right? So what's that leave me with? Well, on this side, I'm left with m, and on my other side, I'm left with v times d. So I'm going to write d. And that's my final answer. Because when numbers or variables are next to each other like that, that means it multiplies. So I don't have to write the time symbol in between. Okay? Let's do another one. This one's got a fraction. Okay, so if I wanted to get rid of a fraction, how do I do that? I have 1 over 2. That means to get rid of a fraction, I got to times it by the reciprocal. So I'm going to times it by 2 over 1. And the whole reason we do that is a half times 2 gives me x, gives me 1x, and that's what I want. I want 1x. So now I got to do the same thing to this side. I got to times this side by 2 over 1. 2 over 1 is the same thing as 2, because 2 divided by 1 is 2, right? And 2 times 10 is 20. So that will give me x equals 20. All right. Okay, so how would I solve this? A equals a half BH. So a half BH. Ooh, man. So I have to get rid of my fraction first. So I got to times it by the reciprocal, times it by 2 over 1. And we just talked about that. 2 over 1 is the same thing as 2, right? So I'm going to times this side by 2. Well, what's 2 times a? Well, that would be 2a. All right? This is now gone because I times it by the reciprocal. All right, now this says I'm solving for b. All right, so that means I want to get this b by itself. Well, two variables next to each other means multiply. So how could I get rid of that h? I want to get that h out of here. Well, I could divide by h. Since they're being multiplied together, dividing is the opposite, right? And then I would do the same thing over here. And that's going to leave me with b. So then this is my final answer. b equals 2a over h. All right, let's think back how we solved this type of two-step equation. I have x minus 5 all over a big fraction bar 2, right? Well, fraction bar means divide. So to get rid of that 2, I'd have to do times 2. And I have to do it to both sides, right? 10 times 2 is 20. All right, and then on this side, I'm left with x minus 5. So if I wanted to get x by itself, I would have to do a plus 5, right? To get rid of these and leave me with x. And I would do the same thing over here, plus 5. 20 plus 5 is 25. All right, so the literal equation version of this would be the exact same. It's the same steps. It says I want to solve for w. I want to get this w all by itself. So I see a big fraction bar, so I'm going to get rid of that first. I'm going to do times m, because a fraction bar means divide, times is the opposite, right? So now I'm going to do this side, times m. Well, what's s times m? Well, that's sm. Right? All right, so what's left over? What's left over? Well, I have a w minus 10e. Well, I want to get w by itself, right? So I need to get rid of this minus 10e. Well, how can I do that? Well, it's the same thing as I do here, x minus 5, right? That's like kind of the same. So to get rid of a minus 10e, I have to do a plus 10e. Plus 10e to get rid of this. And that's going to leave me with w on this side. I'm going to write it over here. It might be a little confusing. But then I'm going to write plus 10e on this side. So can I do sm plus 10e? No, I cannot. Those are not like terms. So my answer is just sm plus 10e. So as you can see, it's the same steps as you would solve a normal equation. All these are. It's like the same steps. It's just a little bit more confusing because it's more variables, more letters, and not at the same numbers. You're not getting like a final answer like x equals 25. You're getting something like this. W equals sm plus 10e. Okay? All right, reviewing simplifying expressions. All right, so these I could simplify. All right, and I can simplify these because these are being divided and there's a number in front of my x, but there's a coefficient, right? So if I was doing this, it's the same thing as like 2x divided by 2 plus 4 divided by 2. Well, 2x divided by 2. 2 divided by 2 would give me 1, so I have 1x. And 4 divided by 2 is 2, so it'd be x plus 2. So all you're doing is you're dividing both things in the numerator by the denominator. So if I did this one, 2x minus 4, 2x divided by 2 would give me 1 or 1x, right? Negative 4 divided by 2 would give me negative 2. That's my answer. I can't combine those two, right? Let's try this one over here. 4x divided by 6. Ooh, so 4 divided by 6 would give me a decimal, but I want to leave it as a fraction. So 4 over 6. If I simplify that, I could divide both of these by 2, right? So 4 divided by 2 is 2. 6 divided by 2 is 3. So that'd be 2/3, right? So this is going to equal 2/3 x. And then 6 divided by 6 would give me 1. Oop, I forgot to write my x. 2/3 x plus 1. Okay? All right, let's do some more literal equations. All right, let's remember how to solve this two-step equation. I got 12 equals 4 plus 2x. I want to get x by itself, it says. So how can I do that? Well, I want to get rid of everything that's not with the x, or not the x, right? So I want to get rid of this positive 4. How do I get rid of a positive 4? Well, I would do a minus 4 to cancel that out, right? And that leaves me with 2x. And I would do the same thing over here. 12 minus 4 would give me 8. And then I would divide by 2 to get rid of these and leave me with x. And then divide by 2. 8 divided by 2 equals 4. Right? This is the basic two-step equation. So this is kind of like the same thing. If I'm solving for w, it says I want to get this w all by itself. Just like how this this x had a 2 in front of it, this w has a 2 in front of it. So I want to get rid of this thing here, just like I wanted to get rid of this 4, because this doesn't have an x in it at all. So how can I do that? Well, I would do the same steps I did over here. This is a positive 2l, I would do a minus 2l. I would do a minus 2l to cancel those out, and I would do the same thing over here. So what's p minus 2l? Well, I can't combine those terms because they're not like terms. So that just leaves me with p minus 2l. And that equals 2w. Still left with that 2w. All right, so how can I get w by itself? Well, I can divide by 2. Divide by 2. That gets rid of these 2's and leaves me with w. P divided by 2. All right, so really, remember this is really a 1 in front of there. This is really a 1p. So it's really 1 divided by 2. Well, 1 divided by 2 is just a half. So it would be half p. And then negative 2, because remember that sign in front stays with that, right? So negative 2 divided by 2 would be negative 1. So I can write negative L, because I don't need to write the 1, because it's implied there. All right, let's skip down to this one where it says solve for y, because this is a super important thing you're going to need to know later in this year in algebra. Super important, because solving for y is big for slope-intercept form. All right, so if I was going to solve for y for this one, right? It's just a normal two-step equation. You guys can do this on your own at this point. This is a positive 12. You would do minus 12, right? And then you would divide by negative 1 because there's a negative in front of here, right? So let's solve for y over here. If I wanted to get y by itself, I'm trying to get this y all by its lonesome. That means I want to get rid of the things without the y first. So I'm going to get things rid of the furthest away from the y. And that's that 2x. So to get rid of that positive 2x, I would do minus 2x. To get rid of that. And I would do the same thing over here. 10 minus 2x would give me 10 minus 2x. I can't combine those two because that 10 does not have an x, right? So now over here I'm left with 4y. I'm left with 4y. All right, so now I want to get y by itself, right? So to get rid of that 4, I'm going to have to divide by 4. Divide by 4, and I have to divide this side by 4. All right, so that's going to leave me with y over here, which is what I want. And 10 divided by 4 would give me a decimal. So 10 over 4, I can divide both those by 2. 10 divided by 2 is 5. And 4 divided by 2 is 2, so it'd be 5 over 2. Negative 2, because remember that sign in front stays with it, divided by 4, well, that's a half. 2 is half of 4, right? So it would be negative 1/2 x. All right? Usually, you would rewrite this and put that x value first, right? We always want to put our variables before our constants. You just want to make sure that the signs stay the same. So this is a positive 5 over 2, so that's why it's plus. This is a negative 1/2 x. Negative stays with it. All right, go ahead and try this one on your own. All right, hopefully you tried that last one on your own. This last one we're going to do together in class, because this is definitely a harder problem, but you can do it. Because there's these things called subscripts. Okay, so subscript doesn't mean exponent. It just means this is the first b. All right, that's literal equation. See you next time.